All right, so here we go, guys. I'm just starting right now. It says intro to polar. We're about to start. What you're looking at is a polar grid. It's the same. You still have an ordered pair, but instead of your ordered pair being x, y, so x comma y, this is what you call either Cartesian coordinate plane, the x comma y, or sometimes called the rectangular grid. So instead of x comma y, your ordered pair is going to be r comma theta, where r stands for radius and theta is an angle. See? Now, I have seen some textbooks that say theta comma r, but most, I would say, pretty close to 100% are going to say it's in this format, r comma theta. Nothing crazy. Or how do you feel so far? Ask me, miss.
Oh, she was in my way.
Oh, sorry. So what you do first, you should always look at this first. I know it's weird because in the Cartesian coordinate, you do the x first and then you go to the y. Ask me about this. What's up?
I would say it looks like a unit circle.
Yeah, it kind of is. It kind of is like the unit circle. You see this circle right here? That is a radius of 1. See? So how do you plot a point on this? So let's see. I'm just gonna make something up. Ready? I'm gonna go 3 comma pi over 6. So what you want to do first, you go to the angle first. Do this first. So I'm going to go to angle pi over 6. So you see this pi over 6? I'm looking right here. Really, I'm looking at this whole line. All that is pi over 6. And then you see how I have a positive 3 there? You count the rings in from the x-axis. So this 3 is distance. Not from the x-axis, from the origin. Distance from origin. So here we go. Ready? Pi over 6 comma 3. You count. Here's the origin, and you're going to go in the positive direction. 1, 2, 3. There it is. That's that point. 3 comma pi over 6. See? So what if I give you this? What if I gave you, let me change the color, guys. What if I gave you negative 3 comma pi over 6? So you're going to go to pi over 6 first. You do that first. Here's pi over 6. It's this entire line, because pi over 6 is this angle. And then I can be anywhere on that line. And you see that negative 3? You're going to count backwards. So here, child, how do you count backwards? Start at the origin, and you go backwards. 1, 2, 3, point. That point right there is negative 3 comma pi over 6. And yes, just like you're probably thinking, this point here could also be, if you wanted to, that's also 3 away from the origin, and that's 7 pi over 6. So that point right here could also be 3 comma 7 pi over 6. Ask me.
If 7 pi over 6, or what was I saying? If like it was negative 3, 7 pi over 6, would it be in the 3 comma pi over 6?
Yeah, if it was negative 3 comma pi over 6, or 7 pi over 6, so you would go to 7 pi over 6, and then you go backwards, 1, 2, 3, it would be right there. So that's negative 3 comma 7 pi over 6. So that's why I tell you guys to do the angle first, and then start counting. That's the easiest way to do it. Does that make sense, guys? Perfect. See, you're already pros. Of course, this translates to an x and a y coordinate. We will talk about that all right now. Cool or not cool? All right, let's go to the next page. So what's the difference between rectangular coordinates and polar coordinates? Well, I don't know. Well, I mean, I do know, but LOL. All right, I'm going to choose a coordinate. What coordinate am I going to choose? Let's choose... We should probably choose something that we know from the unit circle. Let's choose first something simple. 5 comma 5. That's rectangular. That's an x comma y. That's a y. So if I want this x comma y, if I want this 5 comma 5, if I want to write this in rectangular coordinate and in polar coordinate, look what I'm drawing. So this is my x5, this is my y5, this is my r. So how would I get the r? Pythagorean theorem. See, it never goes away. 5 squared plus 5 squared equals r squared. Oh, that's a little song. I mean, I can tell the song, but it would sound better if it had different frequencies or different. Okay. I don't know if you could hear that YouTube. I'm recording right now, so I'm talking to my audience. If I have an audience, I don't know. Maybe I won't. LOL. So my R is 5 square root of 2. Does that make sense, guys? All right, now check it out. What, and you guys are all have intuition. What is your intuition telling you about what this angle is? What does your intuition tell you?
45.
Give it to me in radians.
Pi over 2. No. Pi over 3. What? Pi over 4. Oh.
This is pi over 4. Child, why is it pi over 4? Well, this is 5. The horizontal displacement is 5. The vertical displacement is 5. So I can find my angle theta by doing arctan of y over x, and then check the quadrant, of course, right? So that has to be pi over 4 because arctan of 1 is pi over 4. Is there other ways to do it? Yes, you could have probably done arcsine 5 over 5 square root of 2, which is like saying arcsine of square root of 2 over 2 if you rationalize it. But there it is, guys. So what's the relationship? So it says, what's the difference between rectangular and coordinates? Okay, well, 5, 5 in rectangular in polar is, what did I get? 5 square root of 2, comma, pi over 4. Close it. Chop, how did you get 5 square root of 2? Well, I just did Pythagorean theorem. So there's a formula. So check it out. I'm going to go ahead and write it like this. So if I know that, what am I going to write? That cosine of that angle is equal to the x value divided by r, times r times r. See, times r times r. And I can write this. So I can write x. I'm going to write x equals r cosine theta. There it is for x. That's how you find your x. And then the same thing for sine, guys. I'm going to go sine theta equals opposite over hypotenuse. All I'm doing is SOHCAHTOA. Y over r, opposite over hypotenuse, the y value over r. Then again, with this, times r, I get y equals r sine theta. And then what was the relationship to get the r? X squared plus y squared equals r squared. And then what was the relationship to get the angle theta? Theta equals arctan of, let's see, y over x. It doesn't have to be arctan. You could have done arcsine or arccosine. But yeah, there it is. I was going to say something, but I forgot. Oh, yeah. So check it out. I could have gotten this if you, let's say I wanted to go backwards from here to here. I could have gotten my polar and I could have gotten my x and y by just doing this, guys. So look, I could have gotten x equals, assuming you know what r is, right? 5 square root of 2 cosine of pi over 4. And I just want you to observe this. You don't have to write this down. 5 square root of 2 times cosine of pi over 4 is square root of 2 over 2 from the unit circle. Square root of 2 times square root of 2 is 2. And 2 divided by 2 is 1. So 5 times 1, and you get 5. So see, I would have gotten that 5. And same thing with the arc, with the sine. Does that make sense, guys? So there it is. These are my 4 formulas, the main ones. I'm going to put a dot, and dot. So what's the difference between rectangular coordinates and polar coordinates? Well, you can go from one to the other. Rectangular coordinate, you just plot your x and y. For polar coordinates, you're plotting an r comma theta. Are we still okay? Okay. All right, example 1. So these are all in polar. It says find rectangular coordinates for the points with the given polar coordinates. All of these are polar. I want my xy, an xy coordinate. So let's see if we can do it without formulas first, because there are some that are simpler, more easier than others. And then others, we're going to have to use the formula, right? So look, 4 comma pi over 2. So here's what you're going to do first. I'm going to exaggerate the grid. Do the angle first. Pi over 2, it's a positive y-axis. There it is. That's pi over 2. And then I'm just going to go up 4 from the origin. 1, 2, 3, 4, right there. So that coordinate is 4 comma pi over 2. But in rectangular coordinate, that's the same thing as, what's your x value? 0. What's your y value? 4. So if you're right on the y-axis or the x-axis, it's going to be pretty simple to do. There it is. 0, 4. That's an x. That's a y. How do you feel? Sorry, Centeno, if I know you're working on your stuff, but you're like right. Usually when I do this, I'm like, and so you might be like, he's. I, I'm not gonna ask any questions unless you want to participate. It's up to you. Okay. All right. Ready for the next one, guys? So do this first. So check it out. Check it out. Check it out, Pearsall. So I'm gonna exaggerate my x and y. You don't have to. What are you gonna do first? The angle. So here it is from the positive x-axis to the negative. This is pi. And then you're going to count backwards. 1, 2, 3, point. Does everyone see how I got that point there? What is that in Cartesian or rectangular coordinate? Yep. You would have gotten the answer if you would have done the form. Maybe you're like, Chop, I just want to use the formulas. Okay, if you would have used the formulas, you would have gotten the answer anyways. Look, x equals, it says here, r cosine theta. Well, my r is -3. -3 cosine pi. Look what happens. X equals -3. Cosine of pi is -1. What's negative times a negative? Positive. Look, x equals 3. Y equals, I'm just using my formula. You don't have to write this. You can just observe -3 cosine pi. Cosine of pi is 0. So -3 times 0. And look, you get 0. And you would have gotten the same thing. Does that make sense, guys? Okay. Now look at this one. 16 comma 5 pi over 6. So 5 pi over 6 is in what quadrant? 2. So I'm going to exaggerate quadrant 2. I'm going to say this is quadrant 2. And I'm going to say 5 pi over 6 is right here. Theta equals 5 pi over 6. And I'm going to say this is r right here. And I'm just exaggerating. This is r, nothing's to scale. Not to scale. And so there it is. That coordinate there is 16 comma 5 pi over 6. I'm saying that this distance here is 16. Now I'm going to use my formulas. I want the x and y, so I'm going to go x equals, it says here that x is r cosine theta, so I'm going to go 16 cosine of 5 pi over 6. The unit circle never goes away, so 16 times, do y'all remember what cosine of 5 pi over 6 is? Uh-oh. There's 3 of you. Surely one of you. Yeah, square root of what? There you go. What's half of 16? What's half of 16? 8. So put a negative in the front. -8. Square root of 3. That's my x coordinate. My y coordinate is 16 times sine of 5 pi over 6. What is sine of 5 pi over 6? 1/2. What's half of 16? Just 8. That's my y coordinate. So this is nothing more than -8 square root of 3 comma 8. Are we still okay? Okay. Before I draw Roman numeral number 4, and I'll slow down, you remember you always do the angle first. Negative pi over 4. What quadrant is negative pi over 4 in? The fourth quadrant. And look at my radius. My radius is negative. So that means I'm going backwards. So where is negative square root of 2 comma negative pi over 4? What quadrant is that going to be in? 2. Do you guys see how we're doing it? So I'm going to exaggerate quadrant. Well, I guess I'll do the whole coordinate system like this so you guys can see the logic behind it. So here's my x and y axis. You're going to do this first. So negative pi over 4. Theta equals negative pi over 4. So we're going to be looking at this line right here. See? And then I'm going to go backwards, negative square root of 2. So if I go backwards, I'm like somewhere like right there. Negative square root of 2, comma, negative pi over 4. Could you have used another point, another polar point? Yeah, you could have said that's the same thing as 3 pi over 4, comma, square root of 2. All right, here we go. I'm going to get the x and y. We already know the x has to be negative and the y has to be positive. They're both going to be the same magnitude. So here it is. I'm gonna do the analysis right here. X equals parenthesis negative square root of 2 because it's r cosine theta times cosine of negative power 4. Cosine of negative power 4, that's in quadrant 4, so that's going to be square root of 2 over 2. So I have negative square root of 2 times square root of 2 over 2. Square root of 2 times square root of 2 is 2. Divided by 2 is, so it's going to be 1. And I have a negative, so negative times the positive is a negative. Does everyone see how we got negative 1? Okay. And you can already imagine the magnitude is going to be the same for y. So y equals negative square root of 2 times sine of negative power 4. Sine of negative power 4 is a negative square root of 2 over 2. So negative square root of 2 times negative square root of 2 over 2. Negative times a negative is a positive. Square root of 2 times square root of 2 is 2. 2 divided by 2 is 1. So this coordinate is negative 1 comma 1. This point here. In Okay, how do we feel, guys? Do you feel okay so far? Okay. Don't worry, we're almost done. It's not a long lesson. We'll be done pretty quick, guys. All right, this one here, find two different sets of polar coordinates for the points given the rectangular coordinates. Okay, so these are all x, y's. So I want r comma theta. And they want two different sets. So here it is. I'm doing the first one right here. I'm just exaggerating quadrant 1. I'm exaggerating quadrant 1. I don't like how I'm doing those linear lights. Why can't I? Okay, there we go. So that's 1, 0. In polar, so I can either do, hey, relax. We're going to be fine. Ready? I'm doing an r comma theta. Well, I do the angle first. What if I never moved? My theta could be 0. Do you guys see that? And what's the r? 1. So 1 is 1, 0. Oh, look, it's the same. So it's the same in Cartesian and in polar. I could also do a full revolution. So 2 pi. And then make this 1 again, and I'm still in the same location. I could have also done, I know it says find two difference, but I just want to give you guys more. I could have also rotated to pi, and then instead of making r positive, make r negative, so negative 1. Do you guys see all the different ways we could have done that?
Wait, can you re-explain why it's the same?
Because the first one's the angle. That 0 is theta 0. So if theta 0 is the positive x-axis. And then you just make r equal 1, and that's the distance from the origin. So I'm back at the 1, 0. That makes sense? Okay. So look at letter B, or number 2 here. So negative 3, 3. So I'm going to do that one down here. I'm going to exaggerate the quadrant. Okay, negative 3, 3. So there it is, negative 3, 3. What does your intuition tell you about that angle there? Not power 4, but you're close. It is not 5 power 4. That is 3 pi over 4. If you would have done arctan of negative 1, the calculator would have given you negative power 4, but just go backwards. All right, and then to get my r, I need to do Pythagorean theorem. Do you guys see that? So I'm going to go, look, there's my triangle, just in case you don't see it. Negative 3 and 3. I need to get my r, guys. So r equals the square root of negative 3 squared plus 3 squared. So that is, negative 3 squared is 9 plus another 9. So square root of 18. 18 breaks down to 9 times 2. And what's the square root of 9? So r equals 3 square root of 2. Now that I know that r is 3 square root of 2, I need two different sets. Here we go. We're doing r theta, remember. So my r is 3 square root of 2. So I'm going to write 3 square root of 2, comma. And what was my angle? So there's one of them. Give me another point. Because it says to have two different sets of polar. It doesn't have to be 3 power 4. I could have also said what? What if I went clockwise? No, you could have said 7 power 4 and then negative. But okay, let's put 3 of them. What if I said negative power 4? That puts me in quadrant 4. Do you guys see that? and then go negative. So I'm going to say what? Negative 3 square root of 2. Do you guys see that? And then one more, just like Miss Pearsall said, I could have gone 7 pi over 4. That puts me in quadrant 4 again. And then if I go backwards to get back in quadrant 2, what's my r again? Negative 3 square root of 2. So there it is, 3 different ones. Yay or nay? Okay, let's do the visual for this one here. 0, negative 4. So here's the visual for this one. I'm going to write it right here. 0, negative 4. I'm going to be down here. 0, negative 4. Do the angle first. What is this angle from the positive x-axis all the way to here if I go like that? Perfect. See, you guys are already becoming pros. And what's the r? This is the easiest one, guys. Anytime it's right on the x-axis or y-axis, you can do Pythagorean theorem if you want, but there's no reason to. That distance is just 4. Do you guys see that? So I'm going to go, this is the same thing in polar as saying 4 comma 3 pi over 2. You could have also said, let's see, what else could you have said? You could have said negative pi over 2, and then your r would still be positive, 4. What if I choose my angle to be pi over 2? So that's the positive y-axis, but I don't need the positive y-axis. I got to go backwards. What would my r be then? Yeah, negative 4. There's 3 different values. Do you guys see how we're doing this? Okay, here we go. Last one. Negative 1, 1. That is quadrant. Actually, negative 1, 1 is very similar to, I'm just going to write here, similar to negative 3, 3. So I'm going to skip that one. Is that okay with you guys? Okay. Graph all points on the plane. So don't worry, guys. We're almost done. Graph all points in the plane that satisfy the given polar equation. All right. You see how it says, this just says r equals 2? Does it give you any thetas? So you graph all the thetas. So here it is. If it just says r equals 2, that literally just means the radius is always 2. There it is. R equals 2. And you graph all the thetas. You're just going to make a circle. Really, I should have started in the positive x-axis and gone clockwise, but that's fine. Not a big deal. How do you feel? All right, look at this one. R equals negative 2. Do you think that's going to change anything? No. I mean, no, technically it doesn't change anything. I was going to say like where you start, if theta is 0, then it changes the direction, but it's still going to be the same thing. You're still going to just get a circle. Same thing. Cool or not cool? All right. This time they give you an angle. Do they give you a radius? So you're just going to go along the all of pi over 6. So if r, I'm going to color code this. I'm going to color code this one. Put it in blue. If r is greater than 0, I look like this one. I look like this one. And then I'm gonna color the next one in red. If r is less than 0, I look like this. If they don't tell you an r, it's just gonna be that line all the way. How are we feeling, guys? Are we feeling all right? Yeah. Okay. We're almost done. Polar to rectangular conversion formulas. There's 4 major ones. Oh, by the way, you guys get the extra benefit. We're about to take an AP simulation, and you'll probably at the very minimum now have a chance to get the polar problems correct because we're doing it. All right. There's 4 major ones. What are my major ones? X squared plus y squared equals r squared. X equals r cosine theta. Y equals r sine theta. And the angle is r tan of y over x. Cool or not cool? I don't know how much conics you've done, but look, that looks very similar to equation of a circle in equation of a circle centered at the origin for conics. So it says use polar rectangular conversion formulas to show the polar graph r equals 4 sine theta is a circle. Okay, equation of a circle. Equation of a circle. I don't know how you learned it. Tell me if either of these two look familiar to you. X minus x naught squared plus y minus y naught squared equals r squared. Does that look familiar to you? Okay, or maybe you learned it like this. X minus x naught over r, close it squared, plus y minus y naught over r, close it squared, equals 1, where x naught comma y naught is center.
What do you mean by
Not just means initial or some value. In physics, they call the little zero initial. Have you ever heard winners call it V naught or A naught? No, never. Oh, okay. LOL. Sorry, Wentz. Sometimes they just call it the initial value, or but you've never heard winners go V naught. Oh, I need to talk to him. Not that he's in trouble or anything, just to see. Hey, Wentz, if you're looking at my video. So sometimes they call them that, sometimes they don't, just depends. Sometimes they call it initial. I just got used to calling it not because I have I've had professors throughout. Okay, anyways, I'll stop. All right, here we go. I need to make this look like one of these two equations. It doesn't matter which one, whichever one you guys are most comfortable with. So I'm going to figure out that. You guys ready? So the first thing I'm going to do, remember, all I know right now are these equations right here. These four. 1, 2, 3, 4. And here's what I'm seeing. So I see an r on the left-hand side, and I see 4 sine theta. So I see this. And all it takes is just a little bit of experience. Once you have a little bit of experience, you're going to start rolling really fast. So I'm going to multiply both sides by r. Chav, why are you doing that? When I multiply both sides by r, I get this. R squared equals 4r sine theta. So catch up to here. And now, because I have r squared equals 4r sine theta, I can replace it. What can I replace r squared with? Yep. And then look, 4r sine theta. I see an r sine theta, which can be replaced with a... Yeah, so there it is. That's the whole thing, guys. That's like a little puzzle. So I'm going to have x squared plus y squared equals 4y. Remember, this is what I want. I want that. So I'm going to move this to the left, and I'm going to do something called complete the square. So I'm going to write it right here. X squared plus y squared minus 4y equals 0. Oh, Centeno, I think you're done complete the square. So now you can see it in action, right? I think you guys are done to complete the square already. So look at these two right here. I'm going to complete the square. Chavez, why are you completing the square? Well, I need to have it to look like this, so I need a binomial with a square on it. Binomial is just a fancy word for two terms. Group two terms together with a square on it. So I take that 4 divided by 2 and I square it. What's 4 divided by 2? 2, and then 2 squared. So I'm going to put plus 4 right here. Whatever you do to one side, I got to do to the other, because it's magic if you just don't balance it. So this is still technically the same thing. So all three of these terms combined will make this binomial. X squared plus, open parenthesis, y minus 2, close it, squared, equals 4. Are we still okay? All right, there it is, guys. My center, this is the equation, my rectangular equation, and it definitely looks like this. My center is at 0, 2, center. And the radius is 2, because r squared equals 4. So this looks something like this. 0, 2, like that. By the way, your calculator does have polar. I know you guys don't have your calculators now, and we're not in a calculator classroom. But look, I just want you guys to see this. So you guys don't think that we're fake and we're just doing fake math. We never do fake math. So you see this, guys, real quick? Look at this. You see where it says mode? If I go down to polar, so let's see. You see right here where it says function, parametric, and polar? If I click polar, and then you go to y equals, and then look, I can type that equation that they gave me. They gave me 4 sine theta, and look at this, guys. 4 sine theta. I push graph, and look, child, that doesn't look like a circle. My grid is not a perfect, it's not a square grid. So how do I make it a square grid? Click window. Oh no, not window, zoom. And then look, you see the one that says square? If I push that one, look, now it looks like a circle. Oh, you guys aren't entertained? Okay. Yeah, this is awesome. Okay, see? If you were to graph this in decimals, miss, you don't want to be in your house. You want to be here. So we can do. I think I heard you say, I wish I was in my house.
I said I wish I could play Roblox.
Oh, no, not right now, miss. Okay. Last questions, guys. And, well, all right, so let's continue. Yeah, we'll finish this pretty quick. It says plot each point with the given polar coordinates and find the corresponding rectangular coordinates. Okay, so here we go. Letter A. We have square root of 2 comma power 4. What are you going to do first? You do the power 4 first, and then do the square root of 2. So power 4 is like right here. See? Theta equals power 4. And this, I'm going to say this distance is square root of 2. And it wants the rectangular coordinates. Okay, well, since it's power 4, I guess you don't have to if you think about it enough, but x equals r cosine theta. So x equals square root of 2 times cosine of power 4 is square root of 2 over 2. See? So you get 1 comma 1. Square root of 2 times square root of 2 is 2, and 2 divided by 2 is 1. So you would do the same thing for the y, and you'd get the same answer because that power 4, cosine of power 4, and sine of power 4 is square root of 2 over 2. Does that make sense, Bettis? You can ask me. Miss. Feel free. I want you to. No? Okay. All I'm saying, remember these formulas? Now, remember, we got these formulas. We got these formulas from looking at my geometry, right? Of the coordinate plane, right? By doing SOHCAHTOA. So you see those two right there? Yep. All I did was plug it in. If I want the x coordinate, I just went r times cosine theta. So what did I do? I just plugged in the r. This is my r. So square root of 2. And then cosine of power 4. On the unit circle, if you look at the unit circle, at power 4, it's square root of 2 over 2, comma square root of 2 over 2. This is the cosine. That's a sine, remember? And all I did was, okay, well, square root of 2, that's that one. And then times cosine of power 4, it's this one. So square root of 2 over 2. And then square root of 2 times square root of 2. So here's what it is. Square root of 2 times square root of 2 divided by 2. Square root of 2 times square root of 2, the square root goes away, and that becomes 2 over 2, see? And 2 over 2 is just going to be, and you would do the same thing for the r sine theta, but since it's the same magnitude, square root of 2 over 2 for sine theta, sine of power 4, you're going to get the same answer. So this coordinate here is 1 over 1. I need you to ask, miss, if you don't know, please, sometimes I can tell from the faces, from looking at your face, but I can't always tell. We're doing good? Okay. All right, next one, the 1, 0. So that is in the x-axis like this. 1, 0 is right here. That is, by the way, this is my polar. 0 angle and the x value is 1. So there it is. This is the same in rectangular and in polar. So you don't have to do anything.
So when it's on the x-axis, it'll be the same?
When it looks like this. When you haven't moved, when the radian hasn't moved, whatever the r is, it's going to be the same. Now, if it would have been negative 3, 0, it would have been, yeah, it's still the same. We still okay? All right. Let's look at this one. Look at this. 0 comma power over 2. So you do the power over 2 first. But you see how r is 0? So you're at the origin. Because remember the r is the distance from the origin? Yeah. So you're just at the origin. It doesn't matter what the angle is. If the r is 0, you're going to be there. So there it is. 0 comma all thetas really, but I'll put power over 2 there. Oh, they want a rectangular, right? So 0, 0, 0, 0. We're doing okay so far. All right, power over 4. That's quadrant 2, but then I go negative square root of 2, so I'm going to be in quadrant 3. So here it is. So that's negative square root of 2. This distance here, and then power over 4 is this angle. Let me do the little red dot. and then negative square root of 2. Okay, so here we go. I want the x and y coordinate. You can probably already figure it out from letter A. It's going to be negative 1, 1. But just in case, x equals negative square root of 2 cosine of pi over 4. So here it is, but it's negative square root of 2 times square root of 2 over 2. So it's the same deal, negative 1. And then the same thing for the y. I think I said negative 1, 1, but we're in quadrant 3, so it's negative 1, negative 1. Negative square root of 2 times again, cosine of power of 4 is square root of 2 over 2. And again, negative 1. So this coordinate is negative 1, negative 1. How do we feel? We feel okay? Okay. Now these, I think they want me to do polar. Yep. So here we go. It says plot each of the rectangular coordinates and find the two sets of corresponding polar coordinates. So negative 1, 1 point. I'm going to say that's negative 1, 1. So here it is. I need to figure out this angle. Use your context clues. What does that angle look like to you? The magnitudes of the x and y are the same. So that's going to be something over 4. Yep, there's my angle. And then the magnitude. Well, let's see. This is negative 1. That's 1. This is my r. So r equals square root of negative 1 squared plus 1 squared. So the square root of? What's 1 plus 1? So the square root of 2. So there it is. So here's my coordinate. Square root of 2 comma 3 pi over 4. Now they do want 2 coordinates. So I could have said, I guess we'll write 3 coordinates. I'm going to put that's one of them. Here's another one, same thing. I'm going to say negative pi over 4 and then negative square root of 2. And then that will put me back in quadrant 2. Does that make sense? That's fine. Both of those will work. Cool or not cool? Okay. You guys are so happy. All right, look at this one. 1 comma negative square root of 3. So this we're going to have to do a little bit of work, but it's not extreme work. That's quadrant 4, right? Positive x, negative y. So here it is. Here's my point. Not to scale. 1 comma negative square root of 3. And here is my r. So r equals the square root of 1 squared plus negative square root of 3 squared. So I'm just doing Pythagorean theorem, guys. So r equals the square root, 1 squared is 1, negative square root of 3 squared is 3, and 1 plus 3 is 4. So the square root of 4 is equal to 2. So r equals 2. Here comes the tough part. And it's not even that tough, if I'm being honest. I'm going to go to find the angle. Angle is arctan of negative square root of 3 divided by 1. So arctan of negative square root of 3. So tangent, again, I'm going to slow down. I'm going to go slow. So what that means is tangent of some angle gives us negative square root of 3. So remember that tangent is y divided by x. So in quadrant 4, I want the y to be negative. So in quadrant 4, some angle divided by another angle gives me what? I guess I'll say it. In quadrant 4, in the unit circle, if I have a negative square root of 3 over 2 as the y and a positive half as the x, this will give me negative square root of 3. Do you guys see that? And that's what I want. I want arctan of negative square root of 3. So in quadrant 4, what radian gives me that? I want the y to be, I didn't draw it perfect. It's not to scale. It should be closer like that to the y-axis. I want the y value to be negative square root of 3 over 2 and the x-axis to be a half. What angle is that? 7 pi over 3. Not 7 pi, but 5 pi. There it is. 5 pi over 3. Do you see how we did that, guys? Yeah, that one's probably about as hard as it gets. So my coordinate for letter B is, let's see, 2 comma 5 pi over 3. You could have also done 2 pi over 3 and then do negative 2. Because 2 pi over 3 will put you in quadrant 2, and then if you go in reverse, negative 2 will put you back in quadrant 4. Does that make sense, guys? Okay. And then here are the easy ones. 0, 3. So that's how this is how it looks. 0, 3. In polar, what is this? What is that rotation right there? Pi over 2. What's the R? What's the distance from the origin to up here? 3. There it is. 3 comma pi over 2. They want two values. So I can go 3 pi over 2. And then go in reverse. Negative 3. There it is. Cool or not cool? All right. Negative 1, 0. Negative 1, 0. Here's negative 1. So I could say 1 comma pi. All right. If you do that, you can choose not to rotate. 0 and then negative 1. Go in reverse. You could go 2 pi and then go negative 1 again. Decided to put 3 in there. There it is. We're almost done, guys. We're almost done. Okay, here we go. So for the next 5 problems, replace the polar equation by an equivalent Cartesian rectangular equation. So this means in terms of x and y. In terms of x and y. So you don't want to see an r in there. You guys ready? Don't worry. Look, these are the last problems. After this, we're done, guys. So we have r equals 4 cosecant theta. So first rewrite r equals 4 over sine theta. Cosecant's are reciprocal of sine. We're still okay? Okay, next, I'm going to multiply the right side and the left side by sine theta. Whatever you do to one side, do to the other. Chav, what are you trying to get to? These are the only 4 formulas I know, guys. X squared plus y squared equals r squared. X equals r cosine theta. Y equals r sine theta. And I guess theta equals r tan of y over x. This is all we know. These are my 4 formulas. So that's what I'm using. So then I have r sine theta equals 4. And look at that. Here's r sine theta right there. So I'm going to replace r sine theta with what letter? Y. Y equals 4. There it is. So this is just a line. It's just this line right here at y equals 4. Y equals 4 or r equals 4 cosecant theta if you're in polar. So r equals 4 cosecant theta and y equals 4 will both graph that line. We're doing okay so far? Perfect. Go to the next one, number 4. And what you got to do is find a pattern. So I see r cosine theta, I see r sine theta. And then look, well, r cosine theta is just what? And then r sine theta is just, so there it is. If you want to write it in y equals mx plus b, y equals negative x plus 1. So this will just graph, let's see, positive 1, and then there it is. That's my y equals negative x plus 1, or r cosine theta plus r sine theta equals 1. They both graph the same thing. We got 2 left. Ready? So on this, I'm going to multiply by the denominator. So I'm going to multiply by sine theta minus 2 cosine theta. Whatever you do to one, you do to the other. Sine theta plus, minus 2 cosine theta. So now I'm going to get this. I'm going to get r parenthesis sine theta minus 2 cosine theta. Don't worry, right now we'll distribute the r. Equals 5. And then distribute the r. Bam! Bam! R sine theta minus 2r cosine theta equals 5. See, it's kind of like a puzzle, guys. It's kind of like a puzzle. So it makes things kind of exciting. Are you not entertained? That r sine theta, is this more fun than Roblox? Oh, okay. R sine theta, the same thing as y. R cosine theta is x. Let the record show that the contestant said that yes, this is more entertaining than Roblox. Y minus 2x equals 5. And then just add 2x. Y equals 2x plus 5. Tough crowd, tough crowd. So here is how it looks. Here's 5, and then you have a slope of 2. So y equals 2x plus 5, or r equals 5 over sine theta minus 2 cosine theta. Wow, who knew that that was just going to be a linear line? Cool or not cool? And this one I think is kind of like a little trickery. This is like y equals plus minus x. All right, so here's what I'm going to do with this one. What should I do first? Okay, so we know, so let me write this here. So we know x equals r cosine theta. So from that, if I divide both sides by r, you get cosine theta equals x over r. Right? We know that y equals r sine theta. And so that means sine theta equals y, that's a y, over r. So I'm going to substitute cosine theta and sine theta with these two things right there. Remember that means parenthesis cosine theta close it squared equals parenthesis sine theta close it squared. So I'm going to rewrite this as x over r close it squared equals y over r close it squared. I'm going to square them both, so I get x squared over r squared equals y squared over r squared. And I'll slow down. So then the fact that I have an r squared here in the bottom and an r squared here in the bottom, so that just means that x squared equals y squared. And because we always want to have y equals something, when I square root this, I'm going to put the y first. Y equals plus minus x. Because when you take a square root of something squared, it's plus minus. So that graph would look like this. It would just look like an x, a positive x, and the negative x. Let me draw it better. The positive x. I don't know if that's necessarily better, but oh well. And the negative x. All right, last one. You see, this isn't so brutal, guys. What am I going to do? Well, these are the only formulas I have. I think this is actually going to create a circle. This is a circle. So it needs to look like a circle. So multiply that by r, multiply that by r. So then you're going to have r squared equals 8r sine theta. And then I'm going to replace the r squared with this guy right here. So I'm going to write x squared plus y squared equals, and then look, that says r sine theta equals 8y. R sine theta is y. And then we're going to move the ay to the left. X squared plus y squared minus 8y equals 0. Here. I'm going to complete the square with those two. So let me make some space here. Chav, why are you completing the square? Because I need it to look like this. I need it to look like x minus x naught squared plus y minus y naught squared equals r squared. I need it to look like that for a circle, guys. What's 8 divided by 2?
4.
And 4 squared?
16.
So put plus 16. Whatever you do to one side, you do to the other. That's called completing the squared. And these three terms right here that I'm circling become a binomial with a square on it. Keep the sign. There's a negative there, so it's going to be a minus. So you have x squared plus, parenthesis, y minus 4, close it squared, equals 16. So it's a circle. Circle with center at 0, 4 and radius of 4. R squared equals 16, so r equals 4. And there it is, guys. Are we okay? Now all we got to do is practice. So if this video helped, give it a thumbs up. If it didn't help, I guess give it a thumbs down if you want to. But let me know. And let's work on our delta, guys. All right, talk to you guys later. Bye.